Alright, so here are the goals for today's video. Potentially get the TI-84 banned from the acceptable calculators list on every standardized test. Probably give somebody at Texas Instruments a heart attack, and help you pass your calculus classes. And how are we going to accomplish these goals? Well, obviously, by creating a custom hardware mod that connects the TI-84 to the internet and lets it bypass anti-cheating mechanisms. It all starts with this port here. Have you ever wondered why your calculator has a headphone jack? Well, it turns out it's not actually a headphone jack. It's the slightly smaller 2.5mm jack. It's intended for transfer of like educational programs or other data between calculators and PCs, but of course, the homebrew community has reverse engineered the protocol and written software to connect a microcontroller instead. I got interested in that a while back before I started this video, and here's some of the fun stuff I did. First, I tried just turning on simple electronics like LEDs, which was not too bad. Next was turning on a homemade rumble motor that I had left over from a previous project. And lastly, I made the world's worst N64 controller. And what really caught my attention were the projects that connect graphing calculators to the internet. Imagine if during a test you could just search the web, chat with fellow students, or even download cheat sheets you had prepared beforehand. But you couldn't reasonably bring a setup like this into a test with you. So here's the plan. Find a Wi-Fi enabled microcontroller, cram it into a TI-84, write some special software to get everything talking to the internet, and by the end we should have a cheap, undetectable, ethically dubious, internet enabled cheating device, just in time for the school year.
Disclaimer, Chromalock is not employed to academic show. This video is intended for educational purposes only.
So first things first, we need a microcontroller. To me, the obvious choice was the Seed Studio ESP32C3.
Look at the baby.
I've been using these little modules for a while, and their tiny size and Wi-Fi connectivity are exactly what we're gonna need. One problem though, it's a 3.3 volt system, and the link port uses 5 volts, which would fry our microcontroller if we hooked it up directly. The solution here is a circuit called a level shifter, which converts digital signals from one voltage to another. It's ones and zeros either way, just the voltage that indicates one is different. When I went to buy a level converter, I skipped all the other level converters on Amazon and bought this guy here. That was apparently the wrong decision, because the output of the level converter looks like this. It should look like this. It turns out the much more advanced design of this level shifter is great for high-speed communication on something like a PCB with carefully controlled inductances and capacitances, but not so great for a breadboard, where wires are long and connections are less than ideal. This dumb as bricks design with just a MOSFET and a couple resistors is perfect for low-speed, less than ideal situations, like the 9.6 kilobit protocol of the link port. Fellow YouTuber and engineering god Keith Sachs reminded me that these simple ones exist. Thanks to him for helping me not waste even more of my time. Even with the problem solved now, I don't think I can just let this level shifter that wasted so much of my time get off scot-free. With that out of the way, we can start assembling our modified calculator. All the components fit conveniently in this little area of the calculator's backplate. Power will be provided via the battery terminals here, and the pads for the link port are conveniently exposed on the PCB here. So this came out less than perfect. Besides the fact that I'm apparently using the stiffest wire known to man, the main issue is that I had to include this piece of proto board here. Without getting too technical, it turns out that the pull-up resistors for the level shifter were too weak, and I had to include my own 1K resistors to stop random bits from erroneously being detected. It also doesn't help that my soldering is less than ideal, leading to some pretty bad connections that impact the reliability of this mod if we want to go with the hand-wired approach. So we're finally going to cross something off my channel bucket list. Build a custom PCB. This will be my first real PCB that isn't just a simple breakout board, but thankfully it'll be pretty simple. All we need is a pad to solder the microcontroller to, some MOSFETs, and some holes for some through-hole resistors and connections to the rest of the calculator. I also figured at this point that the mod deserved a name, and given the microcontroller we're using and the device we're modding, TI-32 felt fairly appropriate. But before we send this design off to a manufacturer, I laser cut the outline of the board from some plywood, since I don't want this video to take an entire extra week just because I can't measure. So I placed my order, and about a week later, we have the first PCB of the channel. Well, without any parts soldered to it. The resistors I'm using are just through-hole resistors, which are simple enough to solder by hand, but the MOSFETs are some of the smallest components I've ever dealt with. So we're gonna need my modified digital microscope and my hot plate. I used a 3D printed bracket to mount these lights higher up on the microscope so I could make room for the hot plate to sit under it. That lets me work with hot PCBs and see what I'm doing at the same time. What is important for surface mount components? So all we need to do is apply a couple dabs of solder paste and place the MOSFETs. Don't worry about how my shaking hands made me place the paste in parts a little off center. That'll fix itself once the hot plate warms up. While we wait for that, I'm going to take 5 seconds of your time to quickly mention that I have a Discord and a Patreon that I recently set up. So if you're interested in seeing more of my projects or just harassing me, links are down below. Thanks. After soldering the rest of the components, we're ready to get this board programmed. For the calculator, I just wrote a program that lets you launch one of the many different applets from a menu. Each applet is written in TI Basic and just handles stuff like drawing to the screen and getting user input. But how do they actually communicate with the board? Well, the microcontroller is set up to be impersonating another TI-84, which means that our applets can just use the built-in send and get commands to send or receive variables from the microcontroller. On the microcontroller, there's a list of commands, things like connect to internet, get list of images, or send chat message, each with a unique ID. To start one of these commands, an applet simply needs to just set the C variable to the appropriate ID and send it, followed by any arguments to the command. Most of these commands make requests to a central server running either in the cloud or on a home computer that you expose to the internet. But because the commands may take a while to complete, the calculator has to constantly pull the microcontroller to see if the operation is done. It's the code equivalent of that annoying kid who's constantly asking, "Are we there yet?" But it totally works. Finally, the calculator again uses get to get the results from the microcontroller, whether that's a picture, a message, whatever, and displays that to the screen. I've glossed over the details, but if you're anything like me and want to see those details, check out the GitHub repo for this project. And I think we can finally put this thing together and show its true potential. As you can see, there's no way to tell if this mod is installed just through visual inspection, which will probably get you by most paranoid teachers. Once powered on, you may be confused by the lack of a launcher program. This is intentional, as a pre-installed launcher would be easily spottable, and teachers have methods to stop students from using programs, like wiping the memory of the calculator or putting it into test mode. To get around this, you first need to set the P variable to a password that you had previously set in the firmware, and then send it manually. Then, with the microcontroller unlocked, you set C to the command ID for download launcher, and then send it manually again. When this command executes, it'll transfer the launcher program to the calculator by emulating the silent link transfer functionality supported by the TI-84. Turns out that test mode doesn't disable the send or get commands, and one of the easiest ways to get a calculator out of test mode is just to send something to it from another calculator. So this download launcher command actually does two things. It lets you not have it pre-installed on your calculator, and it also will break you out of test mode if your teacher decides to use it. But with the launcher now installed, we've got 4 different applets specifically designed for test taking now available. To demo them, I grabbed this SAT practice book from a local thrift store, alongside a PS2 DDR pad and a broken ring light that just needed a simple rewiring. We're not going to be using those last 2 items, I just thought they were good finds and I was kind of excited about them. Now for this demo, I have the server hosting all the static files running on my local PC, exposed to the public internet using ngrok. On my phone, I have a hotspot running. To make sure this was a reliable setup, I brought my calculator along with me on a quick drive to the local arboretum. It was able to stay pretty consistently connected to the internet during the drive, with only a few little hiccups, so it should definitely hold in a more controlled environment like a testing center. Speaking of testing, let's look at some problems. For simple ones like this, I'd recommend using the ChatGPT applet. It's fairly fast to type the question in, and ChatGPT is actually reasonably good at answering algebra problems. Sure, it'll occasionally get some questions wrong, but basic definitions and common facts aren't a problem for it at all. And it's way better than trying to navigate a web browser on a low-resolution screen like this. However, more wordy problems like this would be an absolute nightmare to try to get into a text prompt. And how would you even begin to type in a graph like this? To tackle these problems, I've developed a few other tools, first of which is the chat app. If you have no clue how to solve a problem but you think a friend of yours might, you can ask in the chat room. Now I wouldn't have a lot of confidence in friends who need a calculator specifically built for cheating to pass a test, but if you can convince one smart friend to help you out, then you're golden. Need some motivation to help you get through a long test? Why not pull up your waifu in the image browser applet? You can browse images with the left and right keys and select an image with a number key. This would be a great place to put a visual cheat sheet or other reference photos. But if we're talking cheat sheets, we need to talk about the app browser. This app does 2 things. For one, it'll let you download games and stuff to play after you're done with your test, but because you can also store notes in the source code of programs, it also functions as a cheat sheet downloader. So just like with the launcher, if a teacher has you clear your memory before a test, then you'll still be able to get back your cheat sheets by downloading them from the central server. I'm sure some of you are going to wonder about this camera option here. If you're interested in what that's all about, subscribe and I'll be making a video on this in the future. And I think that's everything. You can find the GitHub repo, Patreon, and Discord links down below. I especially want to thank the folks who have subscribed to my Patreon before this video even came out. The support means a lot as somebody trying to work on bigger and more involved projects. I'll be posting more stuff there soon, as I'm heading down south to help repair a pretty awesome machine this next week. And as always, thanks for watching, and you should be seeing more from me in a month or 2.